Hello and welcome everyone. It's actually the last lecture of the current Coffee and Byte series. This series was organized by the subject librarians for the sciences at the University Library, Bern. My name is Aline Frank. I'm a subject librarian for biology. Today we have Michael Horn with us, and he will talk about differences in data visualization tools, in particular Excel and Python.
Hello everybody, welcome to my little talk today, data visualization, Excel versus Python, when to use which approach. I will give you first a very small introduction in Excel and the Python tools that I have used, just say some words to that, and then show you some examples of data visualization with respect to data size and data complexity in Excel and Python, and with respect to chart and plotting types, both in Excel and Python, and then come to a personal conclusion that I have. Now you guys, of course, know Excel. Nearly everybody works with it. It's a Microsoft product, a desktop application that costs money, so you need to pay for it. However, it has a very intuitive handling. It's multifunctional. It has a lot of different, really useful things that it can do. So usually you would work with spreadsheets for data handling. It allows complex data, analyze it with pivot charts, for instance. It allows data visualization, which is the concern of today, but it has some relevant limitation in comparison to the Python tools, which I would like to highlight today. What I call Python tools is a set of tools that are open source, non-proprietary, and transparent, so you don't have to pay for it, and the source code is visible. Python itself is a programming or scripting language. You can use it in very different ways. It's easy to learn. It's very powerful and flexible. It very often is used together with Jupyter notebooks, especially in a scientific context, which is a browser-based application that integrates code output, and documentation. And then there are things called packages or libraries that come together with Python and that allow specific functionalities. Pandas, for instance, is a library for data processing, and Matplotlib one for data visualization, libraries that I standardly use. They're fast, powerful, flexible, easy to use, and very robust. Now, this being said, I would jump into some examples when to use Excel, when to use Python. So imagine you have a small and simple data set. A typical scenario would be you manually make your data acquisition and you want just to have some rapid data visualization. A typical situation might be you have some plants growing in two different locations, and you want to measure their size and plot the average and some standard deviation. You usually open Excel and just type in the data, and then you calculate the average and the standard deviation and make a plot. The entire thing doesn't require really deep knowledge of working with Excel. It's very intuitive. It's very quickly ready for use. However, it requires some intermediate steps, such as the calculation of the average and the standard deviation. The very same plot you can generate with Python, as you can see here. What is directly different, what you can see is directly different is, of course, you have code, and you need to write this code. But it has several things that might be better in Excel. So one thing is it requires no intermediate steps. You can see here the data mean is directly calculated and plotted. You don't have to store it in a variable. The same thing is true for the standard deviation. And then you simply plot this thing. What I have figured out is that, or my opinion is that you have a faster post-processing when it comes, let's say, to put Excel labels and so on in your plot. However, it's more intricate, and the general handling is a bit slower than in Excel because you simply need to type the code. In case that you would have such a small and simple data set, I usually work with Excel rather than with Python. Now, what if your data set is larger and more complex? A typical scenario could be that you have a manually or maybe even automatically generated data set that requires a more elaborate data visualization. I have put here a data set, an example data set, which is the iris data set in a CSV format. It has 4 columns with numeric data. It has 1 column with categorical data, and it has 150 data points or rows. You can see in the middle here how the data set would look like in a text editor. And on the right side, you see how it looks like when you open it in Excel or when you open it in Python. Now, if you want to visualize this thing in Excel, then the intuitive workflow would be to open the CSV file in Excel and then to generate 3 data series corresponding to the categories in the species column, which are Iris, setosa, versicolor, and virginica. This requires some manual filtering, copy pasting, selecting of data, and then in the end, you visualize the data, you plot the data. Here in this case, a scatter plot where 2 columns are plotted against each other. The good thing is that this workflow is still very intuitive. So you can, just by figuring out or trying out things, get such a plot. However, it's a little bit more intricate. It also requires manual organization of the data set, and it requires some repetitive executions of work steps because you need to do the very same things for each subset. When we look at how to do this process with Python, then we see we get some more code. So we have a certain amount of code, but there is no repetitive execution of manual work steps because we can work with loops that loop over the different species in this data set and then do the repetitive steps in an automated way. The code is also reusable, so it can be gradually adapted to new requirements, as you will see in a moment when I will show you how to change this code to get another plot. However, the initial effort is a bit higher than in Excel because you need to get the code running for the first time. Maybe in this situation, I would personally tend to use rather Python, but Excel is nearly the same way usable. If it comes to very large data sets, as we have when data is automatically generated and put it, let's say, in CSV files so that we get very large files containing the data set, then things start to become more tricky. I have generated an example data set that puts random values in a CSV format. It has 5 columns with numeric data, and I choose to generate 2 million data points, which means these are 2 million rows. When we do that and we try to open this data set in Excel, then we run into a problem because the intuitive workflow would say just open the CSV file in an Excel worksheet as done before and then visualize the data, but the data cannot be opened in an Excel worksheet simply because Excel is limited in the amount of rows and columns that it can open, and 2 million rows exceeds this maximal limit. So there are actually no pros, it's just cons. So the data file cannot be properly opened and the data visualization cannot be performed as expected. Whereas with Python, there is absolutely no problem in opening this data set as long as it fits in a memory, and the data visualization can be performed as expected. The only pitfall or the only thing that you need to take into consideration is that the procedure can require some computational time in case that the data size is very large. But here you can see it's very simple to make a scatter plot out of this data set. All right, so in this situation, one would, of course, use something else than Excel. So far, concerning the data size and data complexity, now let's have a look at chart or plotting types, the choices that one has. If you look at what you can do with Excel, so then you can see that you have some relevant chart types available. I have put here the ones that I usually use this for scientific data processing or visualization in the life sciences. You even get some chart recommendation from Excel, but one has to say the choices are rather restricted and the chart recommendation can be little constructive. At least that was my impression. When you look at what is possible with Python, especially with Matplotlib, then you can go and have a look at this gallery of Matplotlib. So you have a huge amount of chart types available. You can do a lot of different plotting styles. They're very good, well documented. There are good tutorials and examples of code, how to do that. The choices are much higher. The amount of choices is much higher. However, again, the initial effort is higher because you need to search for code and to get used to this way of working in the first place. I would like to end by showing a usability case or a use case where I would like to show the differences between Excel and Python at a very concrete example. Now imagine you want to do a histogram of the iris sepal length data. It should be separated by species and it should be integrated in one single chart, which means that you have 3 histograms in one chart. It should look like depicted here at the right side in Python, and I tried really hard to get that thing also working in Excel, as you can see it here. And I will give you a short description of what I did to make it work in Excel, and I will also tell you where the problem is. So again, you need to open the file in Excel, and then to do these 3 data subsets manually with filtering, copy pasting, and selecting of data. And then, because you cannot plot 3 histograms in one single chart, you need to generate a set of appropriate bins manually. So you basically make a bar plot that you plot then in Excel. And in order to make a bar plot that is also a histogram, you need to manually generate the bins. For that, you need to load and activate the analysis tool pack in Excel. From that tool pack, you need to use the histogram tools that calculates the bin frequencies for each data subset. And then you need to visualize the frequencies as individual data sets in a bar plot. The problem is that this workflow is very laborious and inefficient, and that it does not actually generate a histogram, but a bar plot that looks a bit like a histogram. Whereas when working with Python, the workflow would be to have some minor changes in the existing code for the scatter plot. Then you get the code for the histogram. So if you look at the left side, here is the code for the scatter plot that I used several slides ago. You see, this is the most important part, is in this blue box. The kind of the plot is scatter, which is then changed to hist. And then there are some minor things that need to be changed, such as you don't have any scatters anymore, so you don't have a scatter size. Instead, you have some bins. And maybe the most important change is that since you're not plotting 2 columns against each other, but just looking at the distribution along one column, you have a slight reorganization of your command line here. Everything else is basically the same. So you see, this is what I meant with that you get reusable code, or that the code can be reused in a very, very efficient way to extend your plotting types, and also to use it also for different data sets. All right, this is it so far. So I would like to finish by concluding when to use which approach. This is my personal opinion that I give you here. So I would say I personally use Excel when the data set is small and simple, when I only need basic chart types, when the use cases are a little complex. If I only want to see some preliminary estimations, to have some preliminary estimations regarding the data, and in case that this visualization is to be used for informal meetings or presentations. If I was a PhD student, I would say if I want to show my data to my supervisor or to share it with colleagues, then a simple data set can be very nicely visualized with Excel. Of course, if the use of code should be avoided, then Excel is one tool that can be very well used. On the other side, Python tools are very good if the data sets are larger and more complex, if they require more intricate charts, if the use cases are more elaborate and the data visualization needs more elaborate handling, if the data projects are reaching a more mature level at a later stage, let's say in a PhD thesis, and if, of course, one wants to have data visualizations for more formal presentations, such as Congress or meetings. And last but not least, also for publications. With this being said, with my personal opinion being shown in this case, I would like to finish. I would like to thank you very much for your attention, and I'd be happy to listen to your questions. Thank you very much.